Welcome students. In today's session, we will discuss on the concepts related to data types and declaration of the variables. Earlier, we have studied something called as a variable while studying tokens, right? Just to brief on, variable means it is the quantity whose value will get changed during the execution of the program. Each of the variables will be having a type of the data. So we are going to study about those concepts in today's session. So first one is data types. Now basically what data types, it tells that what type of data we are going to store in a variable. Okay, now we have come across with this particular term called as a variable now, right? So what a variable is, just to give a quick recap, variable is a quantity whose value can be changed during the program execution. Now we might be requiring the variables in the program in order to store the data or in order to manipulate the data, right? So that particular data, we have to identify what is that type of the data that particular variable stores. Say for example, if we want to perform certain integer operation, like if we want to perform addition, in the addition we can have the numbers to be a whole numbers, or it could be a floating point numbers. In the sense, number could be a whole number, or the number could also contain certain fractional numbers. If it is a normal text, then it may contain a single character, or it may contain a many characters, right? So what type of data it is going to store, right? So in order to identify that one, each of the variables which we declare should be having a associated data type. So that what we call it as a data type of the variable. So, so fundamentally we have 4 different data types in C program. We call them to be a fundamental data types. First one is a char, that is character. Second is int, that is integer. Then float and double. You notice here that each of these words are nothing but these are the keywords. Keywords means they have got a predefined meaning, okay, and are also case sensitive. CHAR, all are in lower case only. If you wish to write in a program, you have to write it in lower case itself. We cannot change the cases here. Okay, so let us try to understand the meaning of each of these fundamental types here. Now, the first one is character. That is what it can store. It can store a single character. If I declare a variable of the type of the data type char, then that particular variable will be storing certain information or certain data, right? That data, it can store a single character, and the size required to declare a variable of the type character is exactly 1 byte. So 1 byte means what? 8 bits. You might have learned by this time the bits and bytes. So 1 byte contains of 8 bits. Okay. Then the range is given here. Just about this particular range we will discuss in the upcoming classes. As of now I will not go in detail about the range. You may not be able to understand at this particular point. So here you just try to understand the data type, the name of the data type, and the size of that particular data type, and what is the meaning, means what it can store the value, what type of value it stores. Okay, so the character is used to store a single characters. Okay, and the size is 1 byte. Just to give a hint what actually this range is, 1 byte as I said, 1 byte means it consists of 8 bits, right? 8 bits in the sense it is consequently you need to write 8 bits like this. 1, say for example 1 0, sorry 1 1 0 1. Okay, it could be any number. I'm just writing a random bits here. 1 1, how many? 1 2 3 4 5 6 7 and one more, that is 8. So each one of these are the bits. So if you write continuously 8, that is 8 bits, that is equals to 1 byte. The range what it tells is that maximum number of the values what it can store, right, in terms of the binary digits. This is in terms of the binary digits, binary values, the total overall range of that particular number. If you just take simply here there are 8 bits, so if you perform 2 to the power of 8, if you perform 2 to the power of 8, this 8 is from what? The total number of bits. Since this is a binary, so 2 to the power of 8, so you get the value as 2 to the power of 8 is something 256. Yes, it is 256, right? 256. If you just calculate this total range here, okay, it is exactly 256. How? Minus, it starts from minus 128 to plus 127. That means what? Minus 128, it starts incrementing, next is minus 127, minus 126, like that it reaches 0, and from then 0 again it keeps on incrementing up to 127. So if you just draw a line here and try to put the numbers, so on this hand you have minus 128, it is minus 128, okay, and on the other hand here you have plus 127, that is 127, okay. So in between you get a 0 as well, right? In between you get a 0. If you count all these numbers, that is from minus 128 to 127, you will get exactly 256 as the range. That what actually this range means. As of now, this much information is enough. If you don't understand this range also, as of now it is absolutely okay, not a problem. Later we will study in detail about what this range is. Okay, now the second data type, fundamental data type, is integer, right? Integer, here whenever we write the int, that means it is an integer type of data. So what exactly this integer means here? Okay, now whenever we are dealing with the numbers in the programming language, the numbers we can say classify into two types. One is the whole number, okay, another type of a number which has a fractional numbers also, fractional part also, a whole part and a fractional part. These two different classification, these two different types are basically stored into two different data types here. One is integer. This integer talks about only whole numbers. Means if I declare a variable of the type integer, then it can only store the whole numbers. In other term, we call them as stores integers. So now onwards, whenever I use the word integer, you need to understand that number is a whole number. Okay, if we use the term integer, now onwards you have to understand that particular number is a whole number. For example, what is an example for a whole number? Say 10. Okay, in this 10 we have only whole number, we do not have a fractional number. Say for example, other example 2, right? Or it can be even say minus 2 as well, right? All these are what? Whole numbers. And in order to store this particular whole number, we can make use of the data type called as int or integer. And the size required for this is 2 bytes. This 2 bytes, this size is with respect to the memory of the computer. So it requires 2 bytes of memory. Now, what if the number is not a whole number, it also contains a fractional numbers, right? Say for an example, 10.5. Consider an example 10.5. So now here what we have a fractional number also. That the number is 10.5. In that we have a whole number and we also have a fractional part. And we want to store this value, the entire value 10.5. In such cases, such variables have to be declared as a float number, float variable, wherein this float allows us to store a decimal as well as the fractional part. The decimal as well as fractional part, and this fractional part can have a 6 digit of precisions. Means after the decimal point, after this particular decimal point, on the right side whatever we write, we can store up to 6 digits of the numbers, 6 digits of the, after the decimal point we can have 6 digits in the float, and it requires 4 bytes of size in order to store. Okay, so float can support what? It can support the fractional part as well. So try to understand that it can it not only the fractional part, but along with the fractional, the entire number, that is 10.5, will be stored in a variable if that is marked as a float number. Okay, now what if this particular, the precision what we said, 6-digit precision, if we are in a requirement of storing a big number, after the 6 we need to store say 10 precision numbers, after the decimal point there are 10 digits, then how to store that one? In such cases we have to make use of the another type of the data type called as double data type. So again, this double data type can store the decimal point as well as the fractional point. So we can store the fractional numbers as well here. And it supports what? 14 digits of precision. Means after the decimal point, we can have up to 14 digits of fractional numbers. And it requires 8 bytes of storage. 8 bytes of storage. So from this particular side, if you can understand the main things, that is, there are 4 different fundamental data types. Character stores a single character and it requires 1 byte of memory. Secondly, that is int, that is integer, which is capable of storing only whole numbers and it requires 2 bytes of memory. Next is, in order to store the fractional points, we have got 2 different types of data types. How they do differ? They differ in the precisions. Float will have maximum of 6-digit precision, whereas the double will have 14-digit precision, and float requires 4 bytes and the double requires 8 bytes. Okay, this next concept is something which is very important: variable declaration. So variable declaration in the sense, in a program, as I said, if we wish to manipulate the data, if we wish to store the data, or if we wish to add any 2 numbers, we need to first declare the variables. So the variable has to be declared before we use it in the program. It is simple, just simple like this. Suppose if you wish to learn, if you wish to study BCA course, first you have to take the admission in one of the college. Right? In the same way, in the similar way, if we wish to make use of the variable, so we have to tell to the compiler that I am going to use a particular variable, right? So the particular variable, in the sense that variable should be belonging to one of the data type. Okay, so all the local variables means the variables which are part of the main function. So all the local variables are declared in the main function section. Earlier we had studied the main function consists of 2 different sections. One is the declaration section, where we store or we declare the variables, and the second is execution, that is the statements which belong to the execution of the program. Okay, so when we declare the variables, okay, it tells 2 things to the compiler basically. Okay, whenever we declare any variable in the program, 2 things happens. First is the name of the variable. That is, we are going to tell to the compiler that I am going to use so and so variable. Okay, the name we have to provide. That name will be given to the compiler. Second is the data type that is associated with the variable. What type of the data type? Suppose the variable could be of integer data type, that is int. It could be of a character data type, that is char, or even it could be of a float data type. Right? So whenever we declare the variable, it tells 2 things to the compiler. First is the name of the variable. Secondly, the type of the data or the data type associated with that particular variable. Okay. So the syntax. Okay, here you are coming with a new word called as a syntax. I will explain this what syntax is in a later session, slide here. Okay. Data type var1, var2, var_n and semicolon. So basically, in a simple term, a syntax means these are the rules of writing a statement in a given program. So if there is a particular programming language, in that programming language we are going to write certain statements. Those statements should be adhering to the certain rules, okay, that particular program should follow. Based upon those particular rules only, we have to write the statements. So that what we call it to be a syntax here. Okay, so the syntax of declaration of the variable, what it says, the data type first we need to write what data type it is, like whether it is going to be an integer or a character or a float, what data type it belongs, then give a space and then name of the variable. Now here whatever this var1, var2 or var_n are there, these are nothing but the name of the variable, right? So if there are many variables, then each of those variables can be separated by a comma. Okay, first variable name comma, second variable name comma, up to how many variables we want, those many variables we can write, and it should get a terminate, that is it should end with a semicolon. That is very important. Okay, let us see certain example here. Okay. Say int n semicolon. So try to understand this particular line, int n. So this int n is what? It is a declaration of the variable. Now try to understand the two things what it tells to the compiler. Okay, we theoretically we said that when we declare the variables, it tells two things to the compiler, right? So int n here, what is the first one? Name of the variable. Here n is the name of the variable. Secondly, the data type of that means what this particular n variable can store. It can store the data which can be classified as an integer data. Means now the n variable can be used to store the integer values. Integer means what? Integer means the whole numbers. Okay. Now second example. Say now in the second example, int space a comma b comma c and semicolon. This semicolon is a must. At the end of every statement we have to provide a semicolon in order to terminate or in order to end that statement. Now here if you notice what this particular statement is telling to the compiler. It is telling that there are three variables declared here. That is name is a, b and c. All these variables belong to the integer data type. Means all these variables are capable of storing the whole numbers, that is integer numbers. Okay, see, let's say take another example here. Float avg. This avg is something average. Just try to understand. Suppose if I wish to store in any program average, right? So that average I can shorthandly write it as a avg. So what this avg is, what this particular statement tells to the compiler, it tells that the name of the variable is avg and it is capable of storing the float data type. Float data type means it can store a decimal as well as the fractional part. Right? So these are the few simple examples of variable declaration. Okay.